Hi, this is the Science Chef. In this video, we'll be taking you through the theories of practicals for the 2024 JUPEB Chemistry Practical Qualitative Analysis. We just uploaded the title value for the volumetric analysis. If you are yet to watch it, kindly check the link in the description. Also, if you are yet to subscribe to this channel, endeavor to do so now and turn on your notification bell or to always stay updated with new uploads. Without much ado, let's go. In this qualitative analysis, we'll be working with three specimens. Specimens P, Q, and S. I will not tell you the name of the specimens. I will only give you the clues that you need to identify the specimens. I want you to do some work on your own. So you carry out independent research to identify the actual specimens. So let's start with specimen P. So specimen P. What's the appearance of specimen P? Specimen P is a white crystalline solid. It's a white crystalline solid. What's the solubility in water? P is very soluble in water. Very soluble in water. Actually dissolves in water. To form a colorless solution. Dissolves in water to form a colorless solution. What will be the effect of P on litmus paper? That's when I see effect of P, effect of solution of P. Solution of P turns blue litmus paper red. These are more or less like the physical properties of P, right? Looking at the chemical properties of P based on the reagents that were given, right? Reaction with aqueous sodium hydroxide or alkalis. P reacts with alkalis to liberate a colorless gas. With a pungent smell. That turns moist red litmus paper blue. Okay, and this happens when the mixture is heated, right? Reaction with aqueous ammonia. P does not react with aqueous ammonia. So with this, you should have an idea of what the cation in P is. Okay? Reaction with aqueous barium chloride and dilute HCl. So P reacts with aqueous barium chloride to form a white precipitate. Which does not dissolve in dilute HCl. So the precipitate formed when aqueous barium chloride is added to a solution of P, right, will remain insoluble in dilute HCl, right? So with this, you have an idea of what the cation and the anion in specimen C are, right? Then there's also one other bench reagent that was added. That one is not common. I'm going to add it here, so I also know how to identify each of the specimen, or how you can use each reagent to identify each specimen. Okay, so reaction with aqueous potassium hexacyanoferrate 3, or what we call potassium ferricyanide, right? When you add this reagent to solution of specimen P, there will be no reaction, it will not react. So no visible reaction. So with this, you can actually confirm what the specimen P is, the cation and the anion present in specimen P. All right, so we move to specimen Q. So specimen Q. So start with the appearance of specimen Q. Specimen Q is a green, crystalline solid that easily gets oxidized when exposed to air for a very short time or for a long time. It gets oxidized easily, right? Then its solubility in water just like specimen P, specimen Q is also very soluble in water. It actually dissolves in water to form a pale green solution. Right? So what will be the effect of solution of specimen Q on litmus? Just like specimen P, the solution of specimen Q turns blue litmus paper red because they are both salts of strong acids and weak bases, right? So they undergo hydrolysis, right? They undergo hydrolysis to form acidic solutions, okay? So solution of specimen Q turns blue litmus paper red, okay? So these are the common physical properties of specimen Q that can be tested on, right? So let's look at the chemical properties. Reaction with aqueous sodium hydroxide. Q reacts with aqueous sodium hydroxide to form dirty green gelatinous precipitate. In drops. Precipitate remains insoluble. in excess sodium hydroxide due to the formation of an insoluble hydroxide, right? So let's look at the reaction of specimen Q with aqueous ammonia. That's reaction of the solution of specimen Q, of course, with aqueous ammonia. Q reacts with aqueous ammonia the same way it does with aqueous sodium hydroxide. So it will give you the same observations. It will react with aqueous ammonia to form a dirty green gelatinous precipitate in drops, which will remain insoluble in excess aqueous ammonia. Now, another thing that you should notice is that when this precipitate is allowed to stand for some time, it will turn dark brown, right? Precipitate will turn dark brown on start. So let's even add that here. Precipitate turns dark brown on standing, which is due to the oxidation of the cation in that specimen Q to a higher oxidation state. So you find out what cation is that. All right. So here, same as reaction with aqueous sodium hydroxide. So let's not waste time on that. So whatever you have on sodium hydroxide, just copy and paste there. Chicken now. All right. Then we have sodium hydroxide, change it to aqueous ammonia. Don't copy blindly. All right. And then reaction with aqueous potassium hexacyanoferrate 3. So the solution of specimen Q reacts with aqueous potassium hexacyanoferrate 3 or aqueous potassium ferricyanide to form a deep blue precipitate. All right. So now look at the reaction of specimen Q or resolution of specimen Q with aqueous barium chloride and dilute HCl. Just like specimen P, specimen Q will react with aqueous barium chloride to form a white precipitate. It remains insoluble when dilute HCl is what? Added. That's with aqueous barium chloride to form a white precipitate. Precipitate remains insoluble in dilute HCl. Right, so with this you can have an idea of what the cation and the anion in specimen Q are, and by so doing you should be able to know what specimen Q is. All right, so let's move to the last specimen, which is specimen S. Specimen S. Start with the appearance of specimen S. Specimen S can come and appear as a blue crystalline solid, or as if it's hydrated, or a white powder. Right, any of this, but the blue crystalline solid is always the more common appearance. Okay, so solubility in water. Solubility in water. S is very soluble. Also very soluble in water. Actually dissolves in water. To form a blue solution. So whether it is the blue crystalline solid or the white powder that is dissolved in water, when once it is dissolved in water, it will form a blue solution, right? That's the characteristic property of the cation present in specimen S. What's the effect of the solution of specimen S on litmus? Just like the other two specimens, the solution of S turns blue litmus paper red, and that's that on the physical properties of specimen S that can be tested on, right? So we now move to the chemical properties. So reaction with aqueous sodium hydroxide. S reacts with aqueous sodium hydroxide to form a pale blue gelatinous precipitate, right? In drops of sodium hydroxide as aqueous. The precipitate remains insoluble in excess sodium hydroxide aqueous, right? So reaction with aqueous ammonia. Just like with sodium hydroxide, S reacts with aqueous ammonia to also form a pale blue gelatinous precipitate. As something happens when aqueous ammonia is added in excess. The precipitate dissolves in excess aqueous ammonia to form a deep blue solution, which is due to the formation of a very common complex. So you can find out what that complex is, I don't know. Okay, then reaction with aqueous barium chloride. Reaction with aqueous barium chloride and dilute HCl. Just like the other two specimens, specimen S reacts with aqueous barium chloride to form a white precipitate and this precipitate remains what? Insoluble in dilute HCl. It doesn't dissolve when dilute HCl is what? Added. And lastly, we look at the reaction of specimen S with aqueous potassium hexacyanoferrate 3. And just like specimen P, there is no visible reaction. So these are the possible tests that can be asked to carry out on the different specimens, right? For specimens P, Q, and S. Now, another test that you should also take note of is stability to heat. Of these 3 specimens, it's only specimen P that will decompose on heating without leaving a residue. Yes, when you heat specimen P, it will decompose to give off a colorless gas with a pungent smell that turns moist red litmus paper blue, and also a liquid, but there will be no solid residue, right? So you can also add that, right? But if others decompose at all, they will leave a solid residue if at all they decompose. It is only specimen P that will not leave a solid residue when it is heated, right? So that goes to the end of our tutorial on the theory of practicals for the 2024 JUPEB Chemistry Qualitative Analysis. If this video is helpful to you, hit the like buttons and subscribe to this channel if you have not yet done so, and turn on your notification bell to stay updated with more uploads. Our next video would be on possible questions and answers on the JUPEB Chemistry Practicals. So please endeavor to share this video with your colleagues or your mates so that they too can benefit from it. So until we come your way next time, I remain the Science Chef. Thank you and God bless.